Hey my amazing warriors, welcome to the BITSAT mock test number 2 with me Shreyas, your physics master teacher, and right now you're going to watch the physics mock test number 2. Yesterday we kick-started this journey with mental ability, logical reasoning as well as English, and it was an amazing and thrilling session. I'm pretty sure you would have seen it, and if you're not, do not forget to check it out on this channel itself. So now it's time for physics with me Shreyas, your physics master teacher, and I'm really glad and happy and very proud to coach and nurture thousands of students, and many of my kids are right now or even graduated from the prestigious institutes in our country as well as abroad. So now it's your turn. So gear up guys and put up a smiley, put up a yo, put up a fire emoji in the chat box. Keep the chat box alive and support each other, help each other. And if you want to know more about me, well, there's always Instagram, captain_Shreyas, that's my handle. So before we begin, do a small favor, smash the like button for all the amazing free mock tests that you keep getting on this channel in English medium. And if you want more such videos, if you want more such strategies, mock tests, and so many other things that we do on the channel, do not forget to hit the subscribe button as well as join the Telegram channel link, which is there in the description box below. Here is the first question coming up on your screen right away. So we have a question on, I think, gravitation. What is the minimum energy required to launch a satellite of mass m from the surface of a planet, mass capital M, radius r, in a circular orbit, altitude is 2r. So I feel we should start straight away with the diagram. So let's say this is the planet and this is having certain radius r and this has capital mass m. You take a satellite and then you push it up by a further altitude of 2r, and over here it goes in an orbit. Okay, you are putting it in an orbit. So what is the minimum energy required to put it into the orbit? So the energy required for this process, that energy required to put it into the orbit, will be the final energy of the satellite minus the initial energy. So obviously that energy difference will come from you, from the supplied energy. So it will be nothing but the energy finally, which is the energy in the orbit, minus the energy of the satellite when it is on the surface, that is the initial energy. So the energy of a satellite when it is in orbit is half gmm divided by the radius with a negative sign. So let's write that down. So it is minus, and then you have g, and then you have mass of the planet, mass of the satellite, divided by 2 into the radius of the orbit. Now this is r, this is 2r, so obviously the radius is going to be 3 times of r. So 3r is going to come over here. So let's just put 3r over here, and here the energy on the surface is purely going to be potential in nature because it would be at rest. There is no kinetic energy as such. So do not use this formula. This is only applicable for satellites in orbit. So it is a combination of kinetic and potential. This energy will just be potential because it is at rest. So it will be nothing but minus gmm divided by r, because the distance of the satellite from the center of the planet is just r. So you are just going to assume the planet as a point mass. Separation is r, so that's why minus gmm by r. That's what it's going to be. Now many terms are common like g, m, m and r. So take g, m and m divided by r as common. Now this will become minus 1 by 6 plus minus becomes plus. That's why it's plus 1. Now 1 minus 1 by 6 is 5 by 6. So this is going to be g capital M small m divided by r multiplied by 5 divided by 6. I believe that should be the answer. And like you can see, option number A is the correct one, 5 gmm by 6r, exactly whatever we got. So this was based on the concept of the energy of a satellite, potential energy, and also the work power energy chapter, where you should realize that the energy difference will come from whatever energy you put in to bring it into the orbit. So energy difference is always final minus the initial energy. So let's go ahead with the next question. I think it's on optics now. So we have a combination of certain medium and certain curvature is also mentioned, and the question is if the gap between these plano-concave lenses is filled with some liquid, then what is the effective combination going to behave like? Now, the moment you see such a question, remember, most of the times you can convert it into a little bit simpler problem and then solve it. Like, I'll tell you what you can do over here. There is a plano-concave lens, this one, okay? This is a plano-concave lens. There is another plano-concave lens. If you take two plano-concave lenses and join their flat surfaces, you will see it will become a concave lens. So the two plano-concave lenses, I can combine them together as a single concave lens. So that's a separate one whose refractive index is nothing but 1.5. So 1.5 is the refractive index. One of the radius of curvature will be 25, other will be 20. So one is 25 and the other radius of curvature will be 20. That is what it is going to look like. Now the remaining part, which is inside, it is like a convex lens but of a different medium. So this part is just filled with certain things, okay, maybe the liquid, and it has a refractive index of 4/3, and the radius of curvature is exactly going to be same because the liquid exactly fits into that space. So yes, the radius of curvature is just going to be, like 20 and 25. Same thing as before. Just the whatever is there here will come over there. Now once you see this, you will realize that the combination can be found by the effective combination of lenses formula, which is just the addition of the reciprocal of the focal lengths. So I need to know individual focal lengths and let's find them out separately. First, starting for the concave lens. So 1 upon the focal length of the concave lens will be mu, which is 1.5 minus 1 into 1 by, so this will be always negative, guys. So minus, because concave lens has negative focal length. So minus 25 minus 1 by, you will have 20 over here. 25 is negative, 20 will be positive because of the sign convention. This is the negative side, that is the positive side. Now if you do the math, 1.5 minus 1 is 0.5, which is nothing but half. Fair enough. And this minus also comes out to be common. So you can take the minus sign common outside. So the LCM of 25 and 20 is nothing but 100, right? So this will be 1 by 25 plus 1 by 20. LCM is 100. So you can see this will go 4 times. This will go 5 times. So this will be nothing but 9 divided by 200, but with a negative sign. So that is the focal length of the concave lens. Similarly, find the focal length of the convex lens, and that will be nothing but 4/3 is the refractive index minus 1. Here the focal length is going to be positive because that's a convex lens. So you will see it will be 1 by 20 plus 1 by 25. That minus becomes plus. Keep that in mind. Now 4/3 minus 1 is nothing but 1/3, and this again the same LCM will be 100. So you need to multiply this with 5 and this with 4. So this will be 9/3, which is nothing but 3 divided by 100. So I have got both of them. So the last step is 1 by F effective. The effective focal length will be 1 by focal length of the concave lens plus 1 by focal length of the convex lens. So I just need to add both these numbers. So it will be 3 by 100 plus minus 9 by 200. That's it. So taking the LCM, you will see 200 is the LCM. Fair enough. So that will become 6 minus 9. That will be nothing but minus 3 by 200. So the effective focal length will be minus 200 by 3. Now this minus sign indicates that it is a concave lens. So it can't be convex for sure. So it should be between B and C option. 200 by 3 is nothing but 66.66 centimeters. So hence it should be option C, concave lens of focal length 66.6 centimeters magnitude wise. That's negative sign leading us to concave lens. So the concept over here was first simplify the diagram. Then when you see there are two lenses, join the lenses using the effective formula, which is just the addition of the reciprocal of the focal length. Is that clear? Everybody with me on this? Keep following it. Don't lose track. This is very important. You go through all the problems. I've kept as many variety and models of question which are very much pertaining to BITSAT and like exams. This will also help you for JEE Mains. This will also help you for any such CET exam that you're giving. Okay, so let's begin with the next question on your screen. After 2 hours, 1/16th of the starting amount of a certain radioactive isotope is remaining undecayed. Now the half-life of the isotope is how much? The question is on the half-life. Let's try to figure this out. Okay, after 2 hours, 1/16th of the starting amount is remaining. 1/16th? Well, 1/16th is something like this. If there was n, then it becomes n by 2, then it becomes n by 4 after every half-life, then it becomes n by 8, then it becomes n by 16. 1, 2, 3, 4. That's 4 half-lives which are decayed. So 4 half-lives is the time spent, is basically the time spent, so that 1/16th of it, 1/16th of it is remaining. Time spent is already given, it's 2 hours. So 2 hours. So basically a half-life will be nothing but 2 divided by 4 hours, which is half an hour. Half an hour is there right over here, option B. That's 30 minutes. Straightforward. You just have to count how many half-lives were there in this particular question. So you just figure out, oh, 1/16, that's half raised to 4. So 4 half-lives are there. So that means you will think about how much will 1 half-life be. It will be the total time divided by 4. That's it, half an hour. Moving on to the next one. All right. So let's move on, guys. A question on AC circuits. A coil of inductance 300 millihenry, resistance 2 ohm, connected to a source of 2 volts. Current reaches half the steady state value in. Let's try to remember what's the equation for charging of an inductor, because I can see RL circuit. So LR charging circuit, current value is final steady state current 1 minus e to the power minus RT divided by L. Now this current is half the steady state value, that means it is I naught by 2 is equal to I naught, and then you have 1 minus 1 by e to the power RT by L. I just have brought this below, that's it. I naught cancels. So half is there, 1 is there, okay. So take that half there, bring these people over here. So 1 by e to the power RT by L will be 1 minus half, which is just half. So that means e to the power RT divided by L is just 2. Take reciprocal, that's it, flip the equation. Now use the definition of log. E raised to something is, some number like 2. That means the log of 2 to the base e will be nothing but RT by L. Now the question is, what is the time taken to reach that point? So T is asked. So T will be L times of log of 2 to the base e divided by R. Now it's just a matter of substitution. L is given to be how much? 300 milli, that means 0.3 Henry. Log of 2 will be slightly more than 0.6, right? Slightly more than 0.6, and R value is given to be 2. Now 2 goes with 0.6, so 0.3 times, so it will be slightly more than 0.3. 0.3 into 0.3 will be 9 point something, all right, almost close to 10. So almost close to 10, that means this will roughly come close to 0.1 because of the decimals. So hence the correct answer should be option A, right? 3 3s are 9, so it will be 9 point something, very close to 10. Now you need to shift the decimals, so that's the reason why you'll get 0.1. That's all. See if this makes sense. Everybody with me on this? All right, cool. So let's move on to the next question. Yes, option A is correct. Oh, amazing. Go to the next question, guys. Come on. a capillary tube of certain radius is immersed in water, the water rises to certain height. The mass of the water in the capillary tube is m. If the radius of the tube is doubled, then the mass of the water that will rise inside the tube will be how much? Interesting question. Let's try to analyze what it means. So this is your capillary tube, and let's say this is the liquid outside, this is the liquid which is there inside. Now this liquid which is there inside, it will have certain mass. That mass of that liquid, okay, in the capillary will be nothing but the density into the volume. Now the volume will be nothing but the area multiplied by the height. Now the area is pi r square, and the height rise of a capillary is given by 2s cos theta by rho g r. What do I see? Well, rho cancels, okay, fine. Pi g 2s cos theta, everything is constant. One of the r cancels. So what I see is everything else is just a constant and only one of the r's remain. So hence the mass is directly proportional to r. Now read the question carefully. You will get the answer within few seconds. If the radius of the tube is doubled, so the radius of the tube has been doubled. So if you double the radius, obviously the mass will also get doubled because it is directly proportional to. So the crux of the problem was, like you can see option B is correct. Yes, the crux of the problem was to find out how is mass affected by radius. So that's the reason why I wrote mass in terms of volume, because I know volume will have height and height depends on the radius. So that's how you need to figure it out. It could have been anything else, who knows, it could be r square, it could be root r. So that will only be understood once you apply the formulas. Before that, I can never guess whether it was proportional, inversely, or some other powers proportional. Okay, moving on. When a metal surface is illuminated by a certain light of this and this wavelength, the maximum speeds are given to be this and this. The work function of the metal is how much? Interesting question. Let's try to do this. So, I think we need to use the Einstein's photoelectric equation because there are two wavelengths over here, right? So there are two wavelengths over here. Work function will remain same, only the speeds will change. Now, if the speeds are v and 2v, kinetic energy, if initially it was k, okay, if it was initially k, the second time it will be, think about it, kinetic energy is half m v square. So if the speed doubles, the square of the speed, that is 2 square, 4. So it will become 4 times. So if initial kinetic energy was k, the final kinetic energy will become 4k. That's one thing. Okay, rest of the things, let's start doing it. So initially, hc by lambda is 400 nanometers is equal to the work function plus the kinetic energy. Okay. Now next time the wavelength is 250, so hc by your 250 nanometer is work function, but the kinetic energy will be 4 times of k. What do I want? I want the work function, that is fine. So how about taking this equation and multiplying it by 4 times? So let's see what do we get. So if we take this equation and multiply it by 4, so I'll be left with hc by 100 nano, because I'm multiplying it by 4, okay, is equal to 45 plus 4k. Why did I do it? Because I'm going to subtract. I'm going to eliminate kinetic energy. So when I subtract these two, kinetic energy will go off completely. I will have an equation only with 5. So let's try this out and see what do we exactly get. So subtracting the two, so I'm putting a minus sign over here. So hc, so let's see what do we get. hc divided by 100 nano minus hc divided by 250 nano will be 45 minus 5. 4k will cancel, so I'll just get a 0 over there. Now hc and nano is common, so hc divided by nano, which is 10 to the power minus 9, and this would be nothing but 1 by 100 minus 1 by 250 is equal to 3 times of phi. That's what I will get over here. Now, rest of the things are pretty much straightforward. All you need to do is take the LCM and all of that. So this will be HC into 10 to the power 9. Now the LCM is going to be 500. Okay, so you put 500 over here. Now that will go 5 times. This will go 2 times. So 5 minus 2 is equal to 3 times of 5. Now 5 minus 2 and 3 both are same. So obviously this will cancel with this. So you will have your phi as 1 divided by 5 into HC. 5 is there, HC is there. These two zeros will go with the 10 to the power 9. It will become 10 to the power 7. So this would become 0.2 into HC into 10 to the power 7, which is 2 HC into 10 to the power 6. 2 HC into 10 to the power 6 joules is right there. Option A, of course. That's the answer. So these two equations you got from your photoelectric equation. The physics part ends over there. The photoelectric part ends over there. After this, you need to realize, since I need to find phi, obviously you will try to eliminate k. And the best way to do that is by multiplying and solving them simultaneously by subtraction. It's just like solving two equations with two unknowns. I just wanted phi. Rest is just mathematical algebraic part. That's all. I hope this is fine. Beautiful question. These kind of questions are very, very popular with all the paper setters. Option A. Okay, now this is a very nice question. There are two shells, conducting ones. Radius are also given. They are connected by a wire, and that in turn is connected to ground. What do you think is the capacity of the system? There are 4 options given. Some of them is 0, one is infinite. This is interesting. 4 pi epsilon naught A plus B. This is 4 pi epsilon naught AB upon B minus A. Give it a moment. If you want, pause the video and then watch. Okay. So what would happen when you ground it? The moment you ground anything, the potential will become 0 volts. Anything which is connected. So this will also become 0 volts. This will also become 0 volts every time. So if somebody adds some kind of charge over here, obviously it will develop a potential, but you can't because it is connected to ground. Instantaneously you will see the charge will flow into the ground because it can accept as much charge as possible. It has a large capacity, so you can give it as much charge as you want. All the charge will just flow inside the earth, hence the capacitance would be infinite. It has a large capacity, as large as you want. That means it has infinitely large capacitance. So it's a direct question, conceptual based. You don't need any formula, just need to understand what is the meaning of capacitance and what is the significance of grounding over here. Moving on, next question based on nuclear physics, binding energy and mass defect and stuff like that. So you have uranium which undergoes fission, it splits. 0.1% of its original mass is changed into energy. So the mass defect, because some mass gets destroyed, that converts into energy and it releases certain amount of energy. The question is, how much is it if you take 1 kg of uranium? Now as per the question, 0.1% goes into energy, and if I have to talk about the mass defect, so the mass defect will be 0.1% of 1 kg. 0.1% is 0.1 into 1 divided by 100, right? So that's what 0.1% is. And all you need to do is, this is 1 kg, so this is into 1. So this is as good as saying it is 10 to the power minus 3. So this is the mass defect. How much energy will be released because of that? So the energy released because of this would be delta m c square. Delta m is 10 to the power minus 3. Speed of light is 3 into 10 to the power 8 whole square. So this will be 10 to the power minus 3. 3 square is 9. This will be 10 to the power 16. So 9 into 10 to the power plus 13. That's it. That's the answer. Just check it out if it is there. Yep, option D it is. So the first part was to actually figure out how much mass is eliminated. So 0.1% of the total mass. So you find out that mass. 1 kg is 0.1%, is 0.1 by 100 into 1 kg. That's it. So if this was not 1 kg, if it was 2 kg, you will put 2 over here. Now use Einstein's equation, delta mc square. That's the most famous equation for mass destroyed, and you will get the answer. As simple as that. It's a huge amount of energy, by the way. Moving on to the next question coming up on your screen. There is a PV diagram given, 3 different processes, process 1, process 2, process 3. Question is, heat absorbed will be more or less in which of the process? Okay, so the best way to do such a question is to actually check where is heat more, where is heat less for everything, and then try to look at the options. Since heat is asked, okay, think about first law, because you cannot get heat directly from PV graph. You have to think about work and all of that. So think about first law. Q is delta U plus the work done. Delta U is a state function. It's a state function. Because it is a state function, initial and final destinations are same. This becomes your initial point. This becomes your final point. Path are different, doesn't matter. Delta U will be basically same for all the path. That means if you want to compare the heat, you just need to check the work. Wherever work is more, their heat is more. Wherever work is less, heat is less. Now, how do you compare work from a PV diagram? You all know that work is nothing but the area under the PV graph. The area under the PV graph. Okay, so let's see. For the first part, what is the area? For the second and the third part. Now, if you look at the first part, okay, it first compresses, volume decreases, and then the volume increases. When the volume is increasing, the area under the graph will be this much. Think about it. This is the area under that graph. Okay, this whole thing. But when it is, this is when it is expanding, volume is increasing. But when it is compressing, then this is the area under the graph. This is the area under the graph. So if you see the total area under the graph from point A to B via C, it's more positive. It's more positive. So I can clearly say that the work done in the first scenario is definitely going to be positive. Because when you compress, work is negative. When you expand, work is positive. Green area is more than the red area. Cool? Okay. Second process. It's an isochoric process. Look at that. There is no area only. So the work done in the second process is obviously 0. Got it? Work done is 0. It's an isochoric. Isochoric, no work done. Now for the third process, again check out which area is positive, which area is negative. Okay, right from here to here, it's expanding, so it will be positive. So the area under this part is definitely going to be positive. But from here to here, while you go, the total area under the graph, well, that's this one. Check this out. This whole area, this area is definitely negative. So it has more negative than positive. So hence the work done in the third process is negative. That's it. That's enough for us to compare work. So obviously work 1 is more because it's positive. Work 2 is less. Work 3 is the least. Naturally Q has a very similar relationship. Q in the first process will be more. Then comes Q2 and then comes Q3. Because Q3 will have negative work. Q2, 0, Q1, positive work. So highest heat in the first process. Accordingly, look at the options. I'm pretty sure you can see option D is the only one which is correct. Third one is less in third as compared to 2. Yep, less in 3 as compared to 2. Other options has one or the other thing which is wrong. So the concept here was first law of thermo. To compare heat, you need to compare work because state function was same. And the second concept was actually figuring out which area is positive, which area is negative, and matching the sign conventions. Only then you get it. So it's a slightly conceptual and tricky question, but if you have solved many questions of this model, this question will look very straightforward to you. There's a common pattern of question again in the competitive exams. Next one, it's a meter bridge question from current electricity. You want to find out the unknown resistance. This is the standard resistance. This is the galvanometer. This is the null point where it shows zero deflection. This is the potentiometer. This is the external battery. So you get that length, I suppose. Where is it? Yes, 50 centimeter mark, 52 centimeter mark. So this is 52. But there is a problem. I can see there is end correction. So the meaning of end correction is this point and this point have their own internal resistance, which change the effective length of the wire. And you need to consider that end correction at both the ends. At A, like you can see, at A, the end correction is 1 centimeter and it is 2 centimeter at end B. So whenever you measure the length from end A, make sure you add that extra 1 centimeter, which is equivalent of that extra resistance at that junction because of that wire being joined over there. So you need to add +1 over here. So the effective length will be 53. Now this is a 1 meter wire or 100 centimeter wire. So the remaining length is obviously 48. But there is an end correction at point B, which is of 2 centimeters. I need to accommodate that as well. So this will become nothing but 50. Now this lengths are given, unknown resistance has to be found. It's like a Wheatstone's arrangement. So the standard formula in this situation is very similar to Wheatstone balanced condition, and that will be this by that resistance is this by that resistance. So it just turns out to be X by 10. I know this is not resistance, but the resistance is always proportional to the length. So the ratio of the resistance is also proportional to the ratio of their lengths. So it comes out to be 53 divided by 50. This 0 goes. So X will be 53 by 5, which is 10.6 ohms. That's it. That's the unknown resistance, and this is how the actual practical is also performed. So you always have a standard resistance. You move this point till you see there is no deflection, and the moment there is no deflection, the Wheatstone gets balanced, and that's it. You would be given the end corrections, you accommodate them, and just take the ratio, use this formula, and you get the any unknown resistance. So the job of a meter bridge is actually to measure any kind of unknown resistance using a standard resistance. It's a beautiful method. Let's move on to the next question. We have a question on ray optics, maybe even total internal reflection as well, and prism. Wow, interesting. The prism's refractive index is given, angles are given. In order that it gets internally reflected, what is the refractive index of that liquid? So the liquid's refractive index is not known. Let's start with some geometrical constructions first. Here it is getting internally reflected. So let me draw a normal. If this is 60 degrees, this would be, obviously this is a right angle triangle, right? So this would be nothing but 30 degrees. This would be 30 degrees. This is 90 degrees. So that means this angle should be 60 degrees. Now this 60 degrees will become the critical angle. The critical angle. So just at around 60 degrees, what happens is, if you incident the ray, then the ray which will just go outside will just happen to be perpendicular. Anything more than 60, you will see it will get internally reflected. So 60 is that critical mark. Just around 60, slightly less than 60, you see the rays are almost grazing the surface. Once it gets refracted, anything more than 60, it just gets internally reflected. Okay, so let's just use our Snell's law. So let's just use Snell's law and see what do we get. So sin I by sin R is 1 mu 2. So sine of angle of incidence, which is 60, upon sine of angle of refraction, which is sine of 90 degrees, will be, this is glass, that is liquid, so it's going from glass to liquid, so G mu L, which also happens to be mu L by mu G. Well, mu L by mu G, mu L is not known. Glass has a refractive index, the prism has a refractive index of 1.5. Great. So I have got a beautiful equation with only one unknown. It's just a matter of time before you solve it. Sine 60 is root 3 by 2. Sine 90 is 1. Mu L is not known. And 1.5 is 3 divided by 2. So just move this around and you will get mu L is equal to 3 root 3 divided by 4. That's it. Now substitute the value of root 3, which is 1.7. So just do the math. So 3 into 1.73 divided by 4. See how much do you get it. So when you do the math, I think you should get the answer as 1.3, okay, or close to that. So see if you are able to calculate that and get the answer close to 1.3. That's the answer. So the point over here was that are you able to find out the angles? So the first part was geometry. Okay. Once you get the geometry, understanding that yes, at this angle, if you are incidenting the light, then the ray which will come out will almost be 90 degrees, but anything more will get reflected. So it's a critical angle. So use Snell's law after that. Make sure you don't make any mistake in this. If you flip this, you will get a completely different answer. So 1 mu 2 is mu 2 by mu 1. That's the concept. And the way I wrote this is because I know that whatever is the first alphabet, that's the first medium. This is the second medium. Glass, first medium. Liquid, second medium. So always write this in order, and whatever is the first letter comes below, the second letter comes on the top. That's how it works. Okay, fair enough. Moving on to the next question. And what do we have? Sonometer and tuning fork, and there is some string, and it's resonating. Interesting. Length of the string is decreased. Then what do you think is the number of beats heard? Okay, let's analyze the situation first. So we have a tuning fork. Okay, the tuning fork has a fixed frequency. How much is the frequency? 392 hertz. Now you have a string with certain tension, and it is producing some standing waves, etc., whatever. And well, it also has some frequency. It is resonating right now. Now the frequency produced by this will be N into V divided by 2L. That's the frequency produced. Initially they were equal. Obviously this frequency was equal to that because they were resonating. It is clearly mentioned. It resonates. Now what have you done? You have changed the length. The moment you change the length, frequency gets affected. Speed is the same. It will not change because tension is the same. So how do I get, how much is the change in frequency? Because only then I can find out the beats. Well, I can write this as F is equal to NV by 2 into L raised to minus 1. Okay, now it clicks that this is also going to involve errors and measurement. Remember, if there is a quantity, depending on other quantities raised to some power, then the relative error can be found out by, adding all the relative errors multiplied by the powers modulus. So actually it is nothing but delta F by F is, N is not changing, V is not changing, 2 is a constant. The power of L is minus 1. So minus 1's modulus into delta L by L. If there are more quantities, plus power into delta something by something, plus power into delta something by something. This is how it works. That's errors and measurement. Okay. Now delta F, I do not know. Frequency, I know it is 392 is equal to minus 1 modulus is just 1. Delta L is 2%, so 2 divided by 100. So delta F will be nothing but 392 divided by 50. Just check this out. How much does it come out to be? Approximately. Just check it out. How much does it come out to be approximately? I think it comes out to be somewhere around 7.8 something. 7.8 something. So this is the change in the frequency. Tuning fork is still at 392. Now the string will vibrate at 7.8 hertz difference. So that would become your beat frequency. That would become your beat frequency, which means option C should be correct. Approximately 7.8 something will be 8 itself. Is that okay, my warriors? Completely based on your knowledge of beats, which is sound and waves. Second concept was errors. So this concept of errors can come many places. So never ever forget that concept. Okay. So that is a very important thing. Moving on, next question. Wow, we have two sources separated by 2 lambda wavelength. There is a screen, I believe, or there is a large screen over there perpendicular. How many maximas do you get on the screen? Interesting. Let's try this out. See, whenever you have two sources, okay, and there is a line over here, when you are at this point, very close to this center over here, there is definitely some path difference. You can see that there is definitely some delta x. Now, as you go little bit far away, okay, when you go little bit far away, you will see that this path difference will actually reduce. And you can see that when you go really far away, you will see that the path difference will reduce. So the idea over here is that whenever you take two sources and you have a line and you are at some random point, as this point P goes on the top, as you go away, the path difference which is there, the delta x will also reduce. Eventually, when you reach really far away, so when you will see that P tends to infinity, you will see that both the rays will roughly be parallel to each other, something like this, because they will be meeting at infinity. Both will go like this. There will be no difference in the path between them. So then delta x tends to 0. That is the next thing you should know. Last thing, if you are just in front of the screen, right over here, you will see one ray will travel more distance and that distance will be exactly d. So here delta x is just equal to d when you are at this point. So when you are at this point, one ray is traveling exactly that distance. So if you understand this, solving this problem becomes a cakewalk. You will not do all this analysis in the actual exam. This is your homework. This is what you do right now. Now solving this problem is straightforward. How? Observe. At this particular point in front of the screen, the path difference will be 2 lambda. Question says, how many maximas will you get? So when I say maximas, it means the path difference should be always n times of lambda. N times of lambda, 1 lambda, 2 lambda, 3 lambda, and so on and so forth. Now as you go up, path difference reduces. So at some point, the path difference will definitely become 1 time of lambda. It will also become 1 times of lambda below here. 0 lambda will never happen. Remember, path difference tends to 0, but it never actually becomes 0. So this is very important. It becomes tending to 0, but never actually becomes 0. So you will never ever find a maxima on the top or at the bottom. So there is a 1 maxima here, 1 maxima here, and 1 maxima here. So that's a total of 3 maximas. Hence the answer should be option B. So these are some really good questions on counting the maximas. Usually the sources are not like this, they are perpendicular this way. Here the sources are like this. So the counting is little bit different. At the screen point, there is a path difference. As you go away, the path difference reduces. Recollect, if the two sources were this way, then at the center point, the path difference used to be 0. That used to be your central maxima, 0 path difference. Here it is quite the opposite. 0 comes to infinity. So that's what this is all about. Okay, so I hope you guys have learned a lot from this. And if you are loving this session, do not forget to smash the like button already if you have not done it. Okay, and also be a subscriber of Enlite. Moving on to the next question, my warriors. So again, you have a resistance wire, you have a battery, and now the resistance wire has been broken down into a square. And now the question is, if you use the same battery and all of that, read the question, it's bent to form a square, same battery, which of the following quantities will increase? Heat, resistance, current, all three, or some of the two, or none of them, I don't know, figure it out. Okay, so let's try to do this. First of all, let's assume that the resistance of the wire was R. Let's say the current in the circuit was I. Obviously current will be nothing but E divided by R. Now heat produced in the circuit, that heat produced in the circuit, or the power loss, will be nothing but E squared by R. Okay, into time, or if you want power, you can just put power, that is fair enough. So power will be proportional to the heat. So this will be the power loss initially. Now the moment you make it into a square, remember that the total resistance was R. So this part will have a resistance of R by 2, and this part will also have a resistance of R by 2. Both are in parallel. So R by 2 parallel to R by 2. So the effective resistance becomes R by 2's half, which is R by 4. You can get it by formula also. Interesting. Resistance has decreased 4 times. So guess what? The current will be E by R by 4, which will become 4 by R into E, which is 4 times of this current which was there originally. 4 times of that original current. Crazy, this current. In fact, even if you look at the power will also change. So power will be E square by R by 4. So it will become 4 times of that old power. This is that old power, the same power P. So what do you see? Current increases, power increases, resistance decreases. So there is only one option like that. Heat and the current will increase. Yep. Resistance will decrease. Heat and current will increase. Resistance decreases by a factor of 4. Cool. So just analysis. Also common mistakes over here. People forget that the resistance will change and how it will change. They make some random mistakes. So be little bit careful about that. Rest all is simple. Current, electricity. Okay. A beautiful question on 2 spherical balls, each of radius r, in a big bowl of radius 3r touching each other. Question is, find the ratio of reaction between the cup, this whole cup, and the sphere, and the normal between the two spheres So what they are actually asking you is, what is the ratio of this? This is N1 upon this. This is N2. Okay. Now I think I have almost drawn the free body diagram. The sphere, it will experience for normal, and yes, there will be one more force, do not forget, and that is nothing but your weight. So the weight will act downwards. Cool? Okay. Let's think about the angles and stuff like that. So if you draw the triangle properly, okay, so that is that center point, okay, like this. This is the center of one sphere, this is the center of one sphere. The base will be 2r. If you draw the altitude like this angle and this angle will be same, this will be theta. Then you will see each side will become r. This will be the altitude. Now this side will not be 3r, be careful. 3r is the entire radius minus r, so the remaining part is just going to be 2r. Center to here is 3r. This part will be entire thing minus that r, so this is just going to be 2 times of r. Okay, so now you can clearly see I get a nice triangle like this, where this is theta, this is r, this is 2r, using Pythagoras, which will be 4 minus 1 into r. So this will be nothing but root 3r in case I need it. Who knows? Now it's just a matter of balancing the forces, trust me. So do I balance it in y-axis? Well, if I do y, then mg will come. What about x-axis? In x-axis there is no weight. So how about balancing the forces in the x direction? So in the x direction, well, think about it. If this is theta, right? Even this will be theta. This angle will be theta. So N1 has a sine theta component in the right side, cos theta component in the y-axis. So the x component of N1, sine component, which will be like this, N1 sine theta, which will be this way, balances N2's entire component, which is going to be this way, because it's in equilibrium. So in equilibrium, they basically balance each other. Cool? Let's see. What will be N1 by N2? Because that's what is asked. Ratio of the reactions. N1 by N2. So N1 by N2 will be nothing but 1 by sine of theta. Sine theta from here will be this by this. So it will be R divided by 2R. So that makes it just 2. That's it. That's the answer. Do we have it? Yep, option B. There you go. So if you look at it that way, solution is not big, but visualization, geometry is good. A lot of people make a mistake here. They instead of writing 2R, they write it as 3R. Common mistake. Second mistake is, or rather second place where people get stuck is realizing that actually it involves geometry. Many people do not know what to do in this question, how should draw the free body diagram, etc. If you take any one of the sphere, you will see only 3 forces, N1, N2 and weight. That's all. And the third place where people get stuck is actually finding the ratio. They do all random things, but you should realize that only in the horizontal direction, weight will not have component. So you will just have a relation between N1 and N2. So that's the reason why I split it in X only. So we have a question on thermodynamics. Let's try and solve this. A cyclic process BACD is shown and PV diagram is also shown. Which of the following curves represents the same process? So it's a graph conversion, pressure volume versus pressure temperature. Try to eliminate. The best way to do that is elimination. So try each and every process and see one of the graphs will not match. Let's say we take AB. If you take the graph or the process from A to B, it's an isobaric process. So isobaric, yes, it is isobaric. Isobaric, it is not isobaric. So this is the problem. So that goes out. Cool. So this option C is definitely going to be out. Next, let's say we choose CD process. CD is isochoric, volume is constant. So if volume has to be constant, remember when volume is constant, then pressure is directly proportional to temperature. So clearly I can see CD graph is not correct in this part. Here it is correct, here also it is correct. Okay, you can see it is pressure proportional to temperature. It has to be an inclined straight line. So definitely it should be between A and B. Okay, now the last part over here, let's try this out. So you're going from A to B, then B to C. You are going from A to B. Look at the arrow mark. Oh my God, look at this. The direction should have been this way. A to B, B to C. Obviously this is wrong. A to B, B to C, C to D, D to A. Correct. This is the option. Let's check this out. Yes, it is. So it's all about elimination and go one step at a time. Check each and every process. You will see something or the other will be wrong. This is how usually these questions are done. Don't sit and draw the graph from scratch. Moving on to the next one. Wow, we have a question on semiconductors diodes. Wow, we have an AC circuit and it's going to be positive, negative, etc. These are 2 diodes. The question is, how will the final output look like between these 2 points, VAB? Okay, the resistances are different. Will it be half wave, full wave? Interesting. Let's try out each part. Okay, let's try out each cycle. So let's say, this becomes positive, this becomes negative. So what will happen is, this is the AC circuit, this is positive, this is negative, current will come out like this. It can't enter diode 1 because it will be reverse bias. So the only way the current can flow is through diode D2, and it will go like this via this resistance of 150 ohms, and it will come back over here. Now between these 2 points there will be some voltage, and that voltage will be that VAB will be nothing but that current flowing into that resistance, whatever resistance is there over here. Okay, there is some resistance over here. Now this current I can just call it as I1. Okay, some current I1 will be flowing in the circuit. Now let's take the other part of the cycle when the current will reverse. So this becomes negative, this becomes positive. So again, let me draw it. This is your AC circuit. Okay, this is negative, this is positive. So the current will come like this. If the current comes this way, it can't go like this because D2 will be reverse bias. So the current has to go this way. So there is no other way for the current to go but like this via this 100 ohm resistance, and it goes via the diode and comes again via this resistance over here. Now again, if you measure that voltage, this time it will be different current into resistance. Why? Because this is 100 ohms, so this current I2 will be completely different. What does this tell you? In each cycle the voltage is different, and the voltage is also going to keep on switching. First this is positive, this is negative because the current is going like this, then the current is going like this. So what it means is, during the positive half of the cycle maybe the voltage is different, and during the negative half of the cycle again the voltage is different. This voltage and this voltage, they are two different things. They are not going to be equal. Okay, they are not going to be equal. So hence you will see that it has different values during positive and negative half cycles. It will not get rectified. Okay, you will always see that the direction also reverses, because you can see first the current goes this way upwards, now the current goes downwards. So yes, the voltage will keep changing the signs but with different values. So it will not be a symmetric graph. Cool? It's a brilliant question. Okay, we have a question on maybe potentials and period of revolution. Okay, there is a potential field given. How will the period of revolution be affected? Now, the moment such questions are given, you should realize that in general your potential used to be inversely proportional to R, and then your time period of a satellite etc. was found, by Newton's laws and all of that. Here potential is proportional to R, so you cannot use the standard formulas which you have derived for satellites. That's a strict no-no. So from potential I think we'll find out field. From field you can find out force. From force you're going to find out, probably using Newton's laws, what's the angular speed and the time period. So maybe let's try and do that. So potential is given, so field as a function will be dV by dr, magnitude wise only. So it will be d by dr of kr, so it will be k, that's it. Now if this is the magnitude of the field, the force will be k multiplied by some new constant. Remember, force is field times charge or mass, so there will be some mass or charge over there. So that's what it is. Now using Newton's laws, what I will do is, if there is a mass which is going in a circular orbit of radius r, okay, there is a force acting towards the center, so there will be definitely centripetal acceleration. So I will definitely say F is mass into centripetal acceleration, but the force is a constant itself. So there is a constant force is equal to mass into centripetal acceleration is omega square into r. That means omega square is inversely proportional to r. Omega is nothing but 2 pi by time period. Whole square is inversely proportional to r. That means t square is directly proportional to r. Cool? That means t is directly proportional to r raised to half. I think that's what is required. Yep, option A is the correct answer. So like I said, First, you find out field. From field, find force. Then use Newton's laws. You will see that it has angular speed. Angular speed is related to time period by 2 pi by t. That should click. That's it. After that, it's a straightforward manipulation. Okay, so brilliant question, because usually time square was proportional to r cube. That was Kepler's laws. Here you cannot see Kepler's law being obeyed. Okay, so one more question coming up on your screen. Let's try this out. Two projectiles thrown with speeds in this ratio acquire same height. One is at this angle. What is the angle of the other projectile? Height is same, so I think we should start with the height formula first. The height formula is u square sine square theta by 2g. Since it is mentioned that the height is same, it just means that u square sine square theta is same. That means u sine theta is same. That means u1 by u2 will be nothing but sine theta 2 by sine theta 1, because u will be direct or inversely proportional to the sine theta. So just substitute everything. The speeds are in the ratio of 1 by root 2. Sine theta 2 is what is asked. Theta 1 is 45, so sine 45 of course. So sine theta 2 will be 1 by root 2. Sine 45 goes there, again it becomes 1 by root 2, so it will become 1 by 2. Obviously sine of 30 is half. Hence the angle should be option C, which is 30 degrees. That's it, done. Brilliant question, right? There you go. Yeah, option C it is. So there we come to an end of this session. But before we end this session, I have some quick update and information for all of you. All those of you who are preparing for JEE, I'm pretty sure you are preparing, right? So there is a crash course which is going on by the best teachers of YouTube, as well as all the teachers who have produced ranks. Some teachers you don't even see on YouTube. They are putting their heart and soul in, making sure that every kid, no matter which coaching you are from, even if you have taken no coaching, even if you have come from self-study, even if, let's say your marks have been really pathetic, 70 percentile, 60 percentile, or even if you want to improve your scores from 95 to 99 or 85 to 95, whatsoever, there is a good chance you can do that in the last 2-3 weeks. So make sure you check out the link which is there in the description box below. You will see that the crash course consists of not just tests, but also assignments for all the chapters, with all the lectures for all the chapters, 11th and 12th included. So this quick, to the point, bullseye strategy will help you improve your percentiles. And these courses are in English as well as in Hindi, English, both languages available. You can check out the link, and you will see that you get enough time for self-study, and these classes are preferably in the evening time. Starts from around 3 o'clock, ends around 8:15. You can also utilize the time later on for your self-study revision, and the time before for other things, mock test, problem solving. See, when you learn from someone, when you see somebody solving just like today, you learn better. So I feel that you too will learn better via this course, and the syllabus will be completed by 9 July. That's the best part. And you will also see that you will have lots of mock tests to give after the sessions are over, and that will help you in the final days, not just for your JEE mains, but also for your BITSAT, CUET and other CET exams. So give it a shot. It's just for 4,499 rupees. It's a limited period offer, and even if you see the batch start date as something else, do not worry about it, because at the end of the day, it's just strategically watching the video so that you save a lot of time. Okay, so check out the link. Make sure you use the coupon code SHHPRO so that you get maximum benefit out of the course. Okay, thank you very much for watching. I hope you enjoyed. Leave a comment of how you felt about the video. Anything you want to say, do not forget to leave a comment. That's it from my side. See you again very soon. Like, share, subscribe. Hasta la vista, Captain Shreyas signing off.